Hello learners, welcome to today's topic. Our today's topic is problems on frequent item set methods and pattern growth approach. So these are the two methods we will take today. Myself Priyanka Gupta, I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. So today I'll tell about first we will take what are the basics related to mining frequent item sets. What are the frequent item sets? Related to basics we will see. Then I'll tell about the problem and solution by the a priori algorithm as well as by the frequent pattern tree, that is FP tree. So mining frequent item sets, what are the basics are there? So there will be a set of items that will be together, that will be called as a item set. So if set of items are there, so that will be called as an item set. If any item set has k items, that is called as a k item set. Means if one item is there, that will call as a one item set. So that will be replaced by k. K is equal to 1, 2, 3 and so on. So an item set consists of two or more item set, that will be called as a item set. If one item set is there, so that will be consist of two or more items. Now, an item set that is occurring frequently, so that will be called as a frequent item set. Okay. Now, the frequent item set mining is a data mining technique, a method that is going to identify the items that is again and again occurring together. Right. So that is a technique that is going to identify about the most occurring frequent item sets. A set of items that will be called a frequent item set when the condition will be there, if it is going to satisfy a minimum support threshold. So that minimum support threshold as well as with the confidence support threshold, minimum confidence threshold. So that will be the minimum support as well as the minimum confidence. So these are the two conditions will be satisfied, then it will be the frequent item set. So suppose support that is showing the transactions within the items, within the transactions with the items purchased together in single transaction. So what is support? Support is a frequency of purchasing an item in a particular one transaction of purchasing. Confidence shows the transactions that where the items are purchased on the basis of other item. So if the one item has been purchased on the basis of other item, so that will be the confidence of that particular item. So these were the support and confidence in the terms of purchasing something. Now, for the frequent item set mining method, we consider only those transactions which meet the minimum threshold of support as well as the confidence. So these are the two requirements there will be for when a frequent item set will occur, when we are going to do the mining. Then there are so many methods and we can say transactions for frequent item set mining. They are a priori algorithm, hash tree, frequent pattern growth tree, vertical data formats. So basically the a priori algorithm and frequent pattern growth tree, so the data related to that will be the horizontal data format, and as well as we can also use the method for the vertical data format. So these are the few methods that has been used to finding the frequent item set. So now we will take the first method of the basics of frequent pattern tree. So what is frequent pattern tree? FP tree. FP tree is a tree-like structure that is made of with the initial item sets of the database. So the FP tree will have the initial items of the database that has been shown in the form of tree-like structure. The purpose of FP tree is going to mine the most frequent patterns. So that is a purpose. So when we are going to mine the frequent item set, we can use the FP tree. Each of the node of FP tree that represents an item of an item set. So in item set, there can be more than one items, but the node that is showing the particularly one item from that item set. While we are going to depict the FP tree. So the root node, there will be the root node, there will be the child nodes, that will be the tree-like structure. So there must be a root node will be there. So root node will represents the null value. So that if null value, suppose from which node that is going to start the FP tree, that will be the null in nature. There will be no any particular transactions. So that will be null, and while the lower nodes represents the item set. And while we are going to the while we are constructing the tree, so on the each node there will be some that will be in there will be in a descending order. So there will be some items, there will be some items, there will be some items, and at the end what we will found all the items. So that there will be the item set. So on the combination of these of the items, there will be the item set. Some of the items will be there in that has been stored in the commas codes. So like this, the representations will be there for FP tree. So the associations of nodes with the lower node, that is the item set, with the other item set, that will be maintained while we are going to form the tree. So what are the associations will be there when we will form the tree? Then after we will going to do the associations. Now the problem is there is a list of items bought by some customers. So there is some items that has been bought by some of the customers in the different 6 transactions. So there is a table purchased item in that particular some of the customers are there. They have been purchased some items, and the items are in the first transaction, the item has been purchased as I1, I2, I3 into T2 transaction, I2, I3, I4, T3, I4, I5, and as so on in T6, I2, I3, I4, and I1. So now we will going to take the a priori algorithm. We are going to apply the a priori algorithm. So in the a priori algorithm, basically we have to set the minimum support and confidence. So while we are going to apply the a priori algorithm, we have to set the minimum threshold of support and confidence. So the first step will be we have to set the support and confidence. So suppose support threshold is there in this for this particular database, that is 50%, and the confidence is there for we have set as a 60%, right? So the confidence that is related to the support threshold, but the confidence that is having the particular values on the basis of support if the particular one item has been purchased on the basis of other item. So that will be more in nature. So that's why that is 60%. And the support we have taken as a 50%. That is the ideal threshold. So now for the a priori algorithm, the first step will be there. We have to set the minimum support threshold as 50%. So we have set the 50%, and on the basis of that, there is a 6 transactions. This is 1, 2, 3, 4, 5, and 6 transactions are there, right? So now we will calculate how many, what are the minimum support is there, what is the actual minimum support count is there. So now on the 50%, while we are going to take it as in the form of numbers, because it is in the form of percentage. So that will be the 0.5. So the 0.5 will be that will be multiplied with the 6. that is a 6 transactions. So that will be the 3. So the number will come out from that 3. So minimum support will be the 3. Minimum support count will be the 3. So that was the first step of a priori algorithm. Now in the second step, we have to scan the table once. So that was the first table that we have to scan again, and then what we have to do, we have to find the combinations. So now we will take the one item set. So what are the we can say the individual items are there that has been purchased in their 6 transactions. So now we will take the count of that will be the support, right? So we will find the frequent item set, one item set, and we will going to order the frequent item sets in descending order of their frequency. So frequency is nothing but that will be the support of each of the items, each of the individual items. So from that table, the first table, which from where we will see the item I1. So there were in first transaction, there were the item I1, I2, I4. But here we are going to take the one item set, that will be the I1. So I1 has been occurred on that 6 transaction 4 times. Like this, the I2 has been occurred 5 times. The I3 has been occurred 4 times. The I4 occurred 4 times. The I5 occurred 2 times. Now we will order it in the descending order. So now the support count, the maximum support count will be the first, and like that we have to order. And the minimum support, that will be discarded also, because we have set the minimum support as 50%. So what are the items will be less than the 50%? That will be deleted, that will be pruned. So now in the table 3, that will be the frequent item. What are the frequent items for, after the one item set ordering a count of each item. So now the items count will be there, and we have order it in a descending order. So now the item 2 that has the most count, that is the 5. So that will be the first. So now we will take the I1, that is 4 count, I3 4 times, I4 4 times. Now here I5, that is the minimum support that has been pruned from that particular list. So in the step 3, that is the prune step, now we are going to see item 5 that does not meet with the minimum support, that is 3. Thus it is going to be deleted. So less than 3, whatever will be there, the support, that will be deleted or pruned from that particular table. So now only I2, I1, I3 and I4, that is meeting the minimum support count, that is 3. So in this, from the step 3, we have found the table 3, that is of frequent items of I2, I1, I3 and I4. Now in the step 4, that is also the joining step of the a priori algorithm. So now this we have to form the 2 item set. So from that, what are the items we have got in the last transaction, last step 3? On the basis of that, we have to form the 2 item set. What have been what is going to be occurred together. So now we have formed the item 2 set. So now we will take the item 2 item set, that is I1, I2 together. So that has been occurred 4 times. I1, I3 3 times. I1, I4 2 times. I2, I3 4 times. I2, I4 3 and I3, I4 2 times. So that is a count of 2 item sets. Now in the 5th step, that is a prune step again. So in that table 4, that is showing that the item set 1, I1 and I4 and I3 and I4, that is not meeting the minimum support. That is 2 here, that is 2 here, that is less than 3. That was the minimum support. So that will again be deleted. So now we will delete that from that, and that will be the count of 2 item set after the pruning of the 5th step. Now in the sixth step, while we are going to do the joining and pruning again. So now we are going to form the 3 item set. So on the basis of this table, particular table 5, we are going to form the 3 item set. So what are the three item set will be there? I1, I2, I3 that has been occurred 3 times together. I1, I2, I4 2 times. I1, I3, I4 1 times. I2, I3, I4 2 times. So this is the table of 3 item set that has been occurred. The items of 3 that has been occurred together. Now we are going to prune the sum of the items that has been occurred together, but that is having the minimum support less than 3. So there are 3. These are the 3 item set that is having the, that is 2, 1, 2. So that will 3 of the items will be deleted. Now from the table 1, find out the occurrences of 3 item set that has been we have seen. Now from the table 5, the last table, find out the 2 item set subset which support minimum support. So now in after the step 5, we have got the items I1, I2, I3 that has been the occurred for 3 times, right? So we can see for the item set I1, I2, I3, the subsets were there. If we will check the 2 item set with particular this table, so what we will found, the subsets were I1, I2, I1, I3, I2, I3. So there were 3 subsets were there that has been we can relate to that from the earlier tables. So that are occurring in the table 5, the size of I1, I2, I3 that is frequent. So now we can relate to that has been occurred as a subset also in the earlier tables, but that is occurred as a frequent item set after the all steps. Now we can see for item set I1, I2 and I4, the subsets were I1, I2, I1, I4, I2, I4 and I1, I4. That was not the frequent, that were not occurred again and again. So as it will be not considered, not occurring in the table 5, so that will not be the not frequent item set. So hence it will be deleted, right? So we can relate these of the subsets of the particular 3 item set from the 2 item set also. So there were the frequency that has been occurred one by one in each steps. So now we have got the only I1, I2, I3 that is a frequent item set as a 3 item set. So in the next step, what we will do, now we have to create the association rules. We have to form the association rules. We have to generate the association rules. So from the frequent item set that has been discovered above the association that I1, I2, I3 were there. So there will have the some possibility. So we will form the what are the items can be there, what are the dependency can be there as a particular one item or dependent item. So there will have the consequent and subsequent. So now the I2, I3, I1, I2 basically that is depends on I3. So for that we will calculate the confidence. So confidence will be there, support of I1, I2, I3 that will be divided by support of I1 and I2. So support of all items that will be divided by what are the consequent items will be there. So that will be that is in the first table what we have found, what are the frequencies there we will count and then we will divide by that. So that will be the 3 by 4 into 100. So that we have to find in the form of percentage. So that will be the 70%, 75%, right? Like this, we will find out the I1, I3 that depends on I2. The confidence, we have to count the confidence is equal to support of these 3 items divided by support of I1 and I3. So that will be that will come out as 100%. Now I2, I3 that will be depends on I1. So confidence that will be calculated on the basis of all items divided by I2, I3 that will be 75%. I1 that will depends on the 2 items that is I2 and I3. So confidence will be there for 75%. So these 4 rules and other rules is also there. So other 2 rules also there. So I2 depends on I1, I3. So the confidence will be there for that 60%. Now the I3 depends on I1, I2. The confidence we have to calculate on the basis of all items divided by the support of I3, because we are finding the I3 depends on other items. So that will be the 3 by 4 into 100, that will be 75%. So we have set the confidence in earlier first step. The confidence we have set as a minimum threshold, minimum confidence at 60%. So here we have find the one association rule that is also having the 60%. So that is equal to or less than. So that is equal to, so we can take that. So all the 6 rules that we have find from that particular I1, I2, I3 for the I1, I2, I3. So this shows that all the above association rules are strong if the minimum confidence threshold we have set as a 60%. So that was all about the a priori algorithm. So these are the different 6 steps we have to do. We have to find out the 1 item set, 2 item set, 3 item set, and then in between we have to check the minimum support. If minimum support is not there, we have to discard that. Then we have to join that, and then again we have to do it for 2 item set, 3 item set, and then what we will found, we have to make some strong rules. So again, if we have to check the minimum confidence threshold. If it is not meeting with that, we have to discard those items, those particular rules, and who are the more than 60% confidence rules will be there, that will be carried out. So that will be the strong association rules. So the a priori algorithm has been used to take the strong association rules. Now for the other example, we will take the frequent pattern tree. So how we are going to find out the frequent pattern tree? In that we are going to find out the patterns that is frequently occurring. So that will be actually depicted in the form of tree-like structure. So here consider this is a data set of supermarket in which we are having the details of 5 other type of transactions. Right? So these are the 5 transactions. In the first transactions, we are having the milk, onion, nutmeg, kidney beans, eggs, and yogurt. In the second, we are having the dill, onion, nutmeg, kidney beans, eggs, and yogurt. So like this, we are having the 5 item sets that has been purchased by some customer. Now, what is FP tree? In FP tree is same like as a priori algorithm, but all the rules that will be depicted in the form of tree-like structure, right? So here again we have to do in the first we can say foundation step is there. We have to set the support threshold and confidence threshold. So suppose support threshold is set as a 50% and confidence is set as a 60% as earlier. So for the FP tree, the first step will be there. Each of the items has a frequency of occurring, right? So the number of occurrences will increase the item's support. So that will be increased with the support of the count. In the next step, we can see in the transactions that kidney beans are occurring in every transaction. So in the we can say in the back what has been purchased by different customers from the supermarket. We can see for the 5 transactions, every time the kidney beans it is occurring. So at the end of the structure, its supports will be the 5 because it is occurring 5 times. So frequency will be the support. But for the first transaction, its support will be the 1. Why? Because in the first it is occurring 1 time. Right? For the 1 transaction, if you will say. For the all transaction, 5. Now, so in this step, and in this second step, we reset the items order by their support degree for the whole of the database, full of the data set. So now, what are the items are there has been not agreed, that has been not satisfied with the minimum support threshold, that is 50%. So that will be deleted from the every transaction. So after the deletion of the transactions with the that is satisfying the minimum threshold, we have got the in the first transaction kidney beans, eggs, yogurt, onion and milk. In the second, kidney beans, eggs, yogurt and onion. Like this, we have found all the item set that is pruning after the minimum support items. Now, in the third step, what we have to do? We have to form the FP tree. So insert the first transaction of the data in the chart, like in the picture. So that I am telling about how to make the different items for the one transactions. So that is actually rule how to we can say how to make root, how to make the first item, and how we are going to so like a 1 2 1 1 1 1, that is a count of that particular item. So that is for the that I am showing for the understanding. So how we have to form for the first transaction for understanding the each step. So for the first transaction, we have to make a root. We have to make a root node. So that will be the null in nature, null, right? So now that will be connected with the other node. So the other node will be all the nodes will be in the form of oval. So the other will be the kidney beans will be there. Kidney beans were there for the first transaction. So what is the count in the first transaction? 1 time. So that will be the 1. Again egg. So now again eggs. X will be the 1. So the frequency is 1. Again yogurt 1. Yogurt 1. So 1. Like this onion. Onion is 1. Onion is 1. So like this milk is last of the item is milk. So that all will be for the first transaction, right? For the understanding. Now in the from the second step, what we can see in the first transaction, we have records of those of the items that is having the 2 item sets, right? So items having the support degree 3 and more than 3 in the whole data set. So for the second transaction, we can improve our tree, that is in the right hand side. Okay, so that is from the second transaction. So in this we can see that all over the support has been increased. So for the next transaction, if we will see, so now what we have to do, we have to do it from the first table. So first 5 transactions what we have got from the supermarket. So on the basis of that, we have to increase the support. So now we have to increase the support by 1 value for each item, if that is occurring in that particular item set, then only. So now we have to increase the frequency of items. If it has been occurred once, if it is not occurred, that will be the same as 1. If that is occurred again, so that will be the 2 in count. So now, because in the second transaction milk is not there, so what we will do in that what I have shown in the first transaction of the picture, how we have created that. Now the root will be there, the kidney beans that has been occurring second time. So the count that will be increased as 2 by 2. Egg that will be increased by 2. Yogurt is also there, but in the first transaction the yogurt were also there, so that will be 2, but it will be related with the eggs. So in the first transaction, that will occur after the egg. So that will be the lower stage we have also to so that will be the yogurt in count if 1 in the first transaction. Now your yogurt that is associated with onion, so onion has count as a 1. Now your onion has been that will be counted as 1 to 2. Now milk has been occurred 1 time, not in this transaction, so we will not touch that. So that was all about the second transactions items, how we are going to depict the FP tree for that. Now we can also improve the FP tree for all the transactions. Here below in this image we can see for the third transactions. So in this transaction we can see the root the root that will be that will be associated with kidney beans, that is in count as 2, so that has not occurred again, so that will be same. Again the eggs will be same, the yogurt will be same, the onion will be same, the milk will be same. The yogurt that has been, that is all about the first transaction. Again the if we will see in the third transactions, I can show you. So here the kidney beans, eggs and milk that has been occurred in third transactions. So we will see in the third transaction what we are telling. So now the kidney beans, eggs and milk that has been again that has been depicted again in a other node, in the form of other node. So if that is related for the first transaction, then we have to add there. Otherwise, we should not have to add there. Now that was that picture has been, that FP tree has been come out of third transaction. Now the solution will be there for the all the steps. In the final step, we can see how the FP tree algorithm that is going to count the support degree. So here all the items having less than 3 support degree, that will be removed. That will be removed, and the frequent item set that will be represented by the curve line. So by the curvy line we have to show the that is associated with each other, that will be associated with each other, and a straight line that is going to represent that a straight line is there, that is having the arrow like pointing. So that is going to tell about the start of any transaction for one call, and it is going to make it a branch in term of a tree. So in the final FP tree, we can found this FP tree like structure. So in that we can see all the curvy line will be that for the representation for frequent items. So the kidneys beans that has been occurred again, so that is frequent. Eggs, that is again frequent. Yogurt is again frequent. Onion and again frequent. And milk is also the frequent item set, that is also occurred again. So all of the items are frequent item sets here. So that the final solution we have got from there, but we will see how we have step by step how we are going to represent, how we are going to consolidate that. So hence the final FP tree we can see here. We will see the other steps that is going to build the final FP tree. So in the FP tree, for the first consideration will be the root node should be null. So root node we have took as a null. So now in the second scan, the first scan of transactions, the item set will be the I1, I2, I3, that is containing the items I1 one time, I2 one time, and I3 one time. So these are the frequency related to that. So that also we have to depict in the picture in the FP tree. But for the understanding of that particular FP tree for the each transaction, we have done like that. But where the I2 will be linked as a child to the root, I1 will be linked to the I2, and I3 that will be linked to the I1. So like that, in the first transaction, we have to conclude the 3 items together. Now in the T2, the I2, I3, I4 that is containing the I2, I3 and I4, where the I1 is linked to the root. I3 will be linked to the I2, and again the I4 will be linked to the I3. So how the items are occurring, in order of that we have to put that items together in the FP tree. But this branch would not be share the I2 node as common, as it is already used in T1. So because of the T1, in the T1 the I2 were there, right? I2 were there, so we will not use. We will extend that I2 node as a child node of this T2 transaction of I2. So like that, in the first transaction, second transaction, we have done that. For the increment of count of I2 by I1 and I3 is linked to the I2 as a child, and I4 will be linked to the child of I3. Now the count will be I2 of 2. I2 count will be the 2, and I3 count will be the 1, and I4 count will be the 1, because I2 has been occurred already in the first transaction, right? So like this, in the second transaction, after the second transaction, we have to increase in that FP tree like this, for the understanding of each of the count, how the count has been going to be increased. Now in the third transaction, for the third transaction T3, the I4 and I4 and I5 that has been occurred. So similarly, a new branch will be I5 linked to the I4, because that has been not occurred in the earlier transaction, both of the two transactions. So the child will be created of I5 is I4. Now in the I4, I1, I2, I4, the sequence will be that I2, I1 and I4. Because the I2 has been already linked to the root node in the first transactions, and hence it is going to be incremented by 1. That will be count will be again as 2, again as 3. So I1 will be incremented by I1 as it is already has been occurred for the T2 transaction. So the I2 will be there in the T1, and as a I2 is 3 and I2 will be 3, because 3 times it has been occurred. I1 that has been occurred 2 times, and I4 that has been occurred only 1 time. So for the 4th transaction, the numbers will be increased like that for the each item. Now in the 5th transaction, the I2, I3, I5 will be there. The sequence will be there I2, I1, I3 and I5. Thus the I2 will be 4, I1 3, I3 2 and I5 will be 1 time. So in the 6th transaction, the I2, I1, I3 and I4 will be there. The sequence will be there I2, I1, I3 and I4. So the frequency will be there for I2 is 5. In the 5th transaction, that has been incremented like 5. The I1 that has been incremented by I4 4 times. The I3 that has been incremented 3, and I4 that has been only 1 time has occurred in the T1 transaction. So now the FP tree will be seems like this. So and null I2 5 times, I4 1 time, I4 4 times, because that has been occurred again in the third, that is from the third transactions, 3 transactions, right? So like this we have to include the all of the branches like this. So that was I have told about the separate transactions, that is a final transactions of each we can say purchasing. So now in the 5th transaction, that is going to be mine of FP tree, that will be the mining part. So in that the lowest node I5 will not be considered, because that is not having the minimum support count, that was the 3, that it will be deleted. So I5 will be deleted. The next lower node will be the I4. So I4 occurs in 2 branches, that will be the I2, I1, I3 and I4. So now the second will be the I2, I3, I4, that is counted as a 1. So therefore I4 will be the suffix, and prefix path will be the I2, I1, I3 for 1 time and I2, I3 for 1 time. Now the conditional pattern will be there for transactional database of FP tree. So that will be constructed now. So that will contain I2 for 2 times, I3 for 2 times, right? So now the I1 will not be considered, because it is not having the minimum support. Now this path will be generated from all of the combination of frequent item sets. So now after all we will get the I2, I4 2 times, I3, I4 2 times, I2, I3, I4 2 times. So for I3, the prefix path would be the I2, I1 3 times, I2 1 time. So that will generate the 2 node FP tree. So there will be the 2 nodes of that FP tree basically, because the that is having the I2, I1 for 3 times and I2 separately for 1 time. So that combinations will be there, but the frequent item set will be there as I2, I3 4 times, I1, I3 3 times and I2, I1, I3 for 3 times. So in this table we can see that is for FP tree. For the conditional patterns also, that I have told about the how to mine that particular FP tree. So that is pattern based of that particular patterns, that is a FP tree patterns, and that is a what we have got from that particular FP tree as a frequent item set. So that is all of the combination of each of the we can say transactions. So that were the item for I4, I3 and I1. So these were the 3 items that has been bought as a frequent item set. Now for the item I1, the prefix path would be the I2, that was for 4 times, and this will generate a single node FP tree. So I2 will be for 4 times, I2 will be for 4 times, that will be linked to the I2 that has been I2 for 3 times. So that frequent pattern will be for that will be the frequent pattern will be that I2 for 4 times. So here we have write the 3, 1, that because last of the transaction we have not including here, that we have writing is a form of 3, 1. That has been associated, and that is a frequent item set, right? So now the frequent item set will be there, I2 and I1. So here for the I1 item set, we have taken the I1 for the 3 times. So these are the frequent item sets. So in the diagram we can see that is a depiction of a conditional FP tree that is associated with the conditional node I3. So here the I1, I2 that is having the conditional node as a I3. So that is the final FP tree after the mining of each of the steps. So that was all about the frequent item set mining with the 2 of the methods, that was the a priori algorithm, and other was the frequent pattern tree. So that was all about today's class. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.